Hi everyone, my name is Ginny Orzel, and I created a tutorial for a basic game to learn the mechanics of how to build a game in Unreal Engine. With this video, you'll see that there is a 25-page document, PDF, and so you can follow along step by step in case maybe I go too fast on something, or you might want to reread some explanations of something. That document is here. I plan on doing more tutorials, and I'm going to break this one up into 2 videos because I think it'll be quite lengthy otherwise. So the first thing you need to do, actually the first thing I need to do, is I need to share my screen. And the first thing you need to do is make sure that you have Unreal Engine. And so if you Google Unreal Engine and you click on the link, it'll bring you to the Unreal Engine site, and you can download the software. Let me hide this so that you can see everything that you need to see. And once you download the game engine, then you'll get a little icon on your desktop that says Epic Games, and it's the launcher, and you double click on that. And it's going to bring up these different tabs up here where you can find out what the latest news is, what's happening in Unreal Engine, some samples, a marketplace, and the tab that we want is the library. And so when I made the tutorial, the latest version I had was 5.1.0, and that was in the documentation. And as I'm doing the video, I just recently upgraded to 5.1.1. So there's a little bit of a difference, and I'll go through those. So let's launch the latest version. And once we launch the latest version, a new window will pop up. And what's really great is Epic Games has created lots of different templates for you to start with so that you can, get the understanding of how the mechanics work in whatever you want to do, whether it's film, video, architecture, or games. So we want to select the Games tab here, and we want to select first person. And I am saving everything to the D drive, and then I'm going to name this. And let's say demo. And then we're going to hit the create. And one of the things that's going to be really important is being able to name things and keep everything organized. And so I don't want to work off just the template. I want to actually save this. I don't want to be just first person map. I want to be able to name it so that I can keep track of the different projects that I'm working on. So I'm going to go up to the top here. I'm going to do File. I'm going to save current level as. And you can see that we're in the content folder. And what I want to do is I want to create a new folder called Maps. Levels, as you can see in this tab up here, it says first person map. This seems to be what whoever designed this decided to call your projects their maps. So it's best to keep them all organized into one folder so that you can easily reference them, and that others who work in the field will understand what this folder is. And so you'll be cutting edge with the technology terminology. And so I'm going to name this let's call it version 1, and then we're going to save it. And so now what I want to do is I want to create another folder in my content browser. Now in 5.1, you can see that when you open up one of the templates, it automatically creates a tab right next to your level tab, which is really nice. If you're using an older version, you might not have that tab, and down in the bottom left-hand corner is the content drawer, and then you can always dock it, so you don't have to keep hitting it to turn it, to open it up. And so in here, making sure that we're in our actual content folder, we want to right-click in the blank area and create a new folder, and we want to call this Blueprints. This game that we're going to be creating, we're going to do it all in Blueprints. And so this will be a great, if you're not familiar with Blueprints, it'll be a great way to start learning and understanding Blueprints. And as a layperson, I don't know if, the best way to describe it, but I would say Blueprints, technically speaking, blueprints are codes, right? It's being able to code, kind of like a computer science major would, but it's kind of more of a GUI system where there's nodes and you can connect the nodes, and the scripting is within the nodes, and you're just kind of connecting the nodes. So it's coding, but in a friendly way, I guess you could say it. And so we want to keep all of our blueprints organized, and you're going to see that we're going to build multiple things in these blueprints. And so we want to have a folder to keep everything organized. And we want it in our main, main folder, the categories. Now, if we double click on the blueprints folder, we're going to right click and we're going to create another folder. We're going to create a target folder, because the first thing we want to do is build a target. So this first person shooter game, where I'm going to create donuts essentially, and we're going to shoot the donuts, and the donuts are going to disappear, and then they're going to spawn. And so as we get rid of them, more will pop up. And to make the game more interesting, the targets will move horizontally, vertically, and they'll scale randomly. I'll also have, a code in there so that some of the targets stand still, because you'll see I'm a terrible shooter. And so I need all the help I can get. But to add a little bit more fun to it, I want to use the torus, which looks like a donut. And then that way, the center is gone. So that'll make it a little bit more interesting. So the first thing we need to do is create our target. And we're going to actually model that right in Unreal Engine. And the reason is I want to make sure that we have everything that we need at our fingertips right in the game. You don't have to, go searching for assets to add to the game to try to make it work. And you don't have to pay for anything either. So really, just to get the mechanics down, and then you guys can make it as fancy as you want later. So let's open up our target folder. And again, we're going to right click in the blank area, and we're going to add a blueprint class. And, what's really cool about these blueprint classes is that they're very intuitive. It's node based, and whether you are the script level, whether you are the designer or the programmer who's going to be writing the scripts, you can very quickly and easily create coding for, a simple game or even a complex game. Our game is going to be simple. And so it's really kind of cool that we'll be able to script different level events as well as actors. So let's hit the blueprint class. And you can see that there are a lot of different classes. And if you hit on the all classes, there's even more classes. So it is quite extensive what you can pick. But what we're going to pick is the actor. And the reason we're going to pick that actor is because this selection will allow us to be able to spawn objects in our game. And we can also place objects in our game. And we want our target to spawn. So this is absolutely the perfect, option for us. So we're going to pick actor. And as you're going to see, naming everything we do is going to be really important. And one of the common things that most people do is, when they're creating a blueprint, they always put BP before it. So BP stands for blueprint, and I'm naming it BP underscore target because this is going to be a blueprint just for the target. And as we go through, you're going to see that, the next step we're going to do is make a static mesh. And so when we make a static mesh for the target, it's going to be SM underscore target. So it helps us to be able to easily identify, the different elements within this game. And you'll see that there's plenty of them. So you can get very disorganized and very lost in all the elements if you don't label it properly. So double click. And the other thing is that you have to know the naming schemes of what you're doing, because sometimes you have to, even though you build them in one area, you then have to reference it and call it up in another menu. And if you don't know how you named it, it can get really ugly pretty quick. So it's really important to try and keep a good naming scheme going so that you can easily find your elements. So now what I want to do is I want to create a target that we can place in our real world so that we can code it so that it will randomly change size and location. But what we need to do first is we actually, because I want to use the torus, which is the donut, they no longer have it in the drop-down menu for you to choose in as the asset for the first person target template anymore. So I'm going to quickly make one, which is really easy to do. You go back to the level, and mine is FPS underscore game underscore version 1. And just underneath that, there's a selection mode. And if we select it, we just click on the modeling. Now, what I want to do is I want to zoom in a little bit, and I'm using my little mouse wheel to move in. And if you don't know, just like you play a game, D moves you left, A on the keyboard moves you, oh, pardon me, I said that backwards. D moves you right, A moves you left. I'm dyslexic, so sometimes I get myself mixed up. My apologies. S moves us backwards, W moves us forwards, Q moves us down, E moves us up. So I just kind of want to be in the game a little bit more. And so I'm going to click on my torus, my donut here. And, so far, all these default settings are terrific. 16 is a little chunky, so you see the edges. So if you want it a little bit rounder, you can increase your slices here so that it's a little bit smoother. And if I, bring my cursor into the area of the environment of our game, you can see this is what our torus is going to look like. And what I want to do is I also want to give it a material. And I'm just going to click on none, and I'm going to click on the base material. And so we can see that that's pretty smooth. And I'm going to click on this well here where the big circle is. And I have two screens, so my my tabs open up in the other screen, but I can just drag this tab and put it up next to my content browser. And if I click on this white well here, then I can change it any color. I kind of like the orangey brown color because it kind of reminds me of a donut, like the plain donuts that you can get at your bakery. That's kind of a little yellow. And so I know donuts aren't shiny, but I really have a thing for shiny objects. I know that's kind of silly, but I really like shiny objects. So I'm going to leave this shiny, but you guys can, change, make it any color you want. And you don't have to have a shiny metallic type, plastic type look. And you can change those parameters if you want. In the upper left-hand corner is where we're going to save it. And now I'm going to go back to my model, and look, it kind of sort of looks like a donut. And if I select the area, it says, create the torus. And I'm going to say, yes, I want to create my torus. And so I'm going to go back to my regular selection, and I'm going to go back to my content browser, because now the first thing we need to do is create a static mesh for our target so that we can put it into our environment and manipulate it, so that we can write the code to scale it, to randomly scale it, to size it, and also to, when we shoot it, it disappears and it spawns as well. So let's double click on our BP target. And the first thing we want to do is make a static mesh. So hitting the plus up here on the add under in our components tab, we're going to type static mesh. And we're going to name this, as I said before, SM_target. And just so that you know, I probably should tell you this too, just so you know, SM stands for static mesh, and a static mesh is a polygon mesh. It's the basic unit that is used in creating geometry in Unreal Engine. And what's really cool about a static mesh is that it can be translated, scaled, and it can be rotated. You just can't animate the vertices. So, but otherwise, it's pretty universal to what you can do with it. So now, making sure that your SM target is selected, we're going to go to our details menu, which is on the right. And in the fourth category from the top, you'll see that it says static mesh. We're going to hit the drop down, and you can see there's our ball that we're going to shoot our targets with. And you scroll down, and there's our torus. And so we're going to select our torus. And there it is, our nice shiny donut. And what I want to do is I want to have it standing up. And so I'm going to go up a couple of categories to the transform. And on the rotation, I'm going to change the X to 90 degrees. And so now it's standing upright. So we can compile and save our donut. And so the next thing, I should probably, I'm kind of jumping ahead a little bit, so I probably should tell you that what we want to do here is keep this as the child of the default scene root, because when and if we need to make changes to the location, the relative location node, it will be much easier keeping this as a child instead of as something independent. And we will be actually later getting into the relative location node. So we do want to keep it that way. So if you have any ideas of taking it out and not making it the child, it may be in your best interest just to leave it alone. So I want to get into now the construction script to be able to randomly scale. And so there's going to be a series of steps. And the purpose of all of these steps is to have the targets randomly move and randomly scale. And so let's get started. So right now we're in the viewport. Let's go to the construction script. And what we want to do is we want to select our static mesh target and drag it into our work area. And now what we're going to do is we're going to drag off of our pin, this that little circle they call is a pin. And what we're going to do is we are going to type set world scale 3D, and you don't have to write the whole thing out, and it'll pop up for you. And so on our left-hand side, underneath our components tab is called a My Blueprint tab or menu. And what we want to do is we want to create a variable. We'll be creating a lot of variables, you know, in the next few tutorials. I'm going to be turning this one into a couple, but I have a couple more that I want to create. And so variables are fabulous because what they do is they hold they're properties that hold a value or reference to an object or an actor in our world. And so what we want to do is we want to hit the plus sign to the right of the word variable so we can add a variable. And we're going to name this actor scale. And this is going to be the variable that is going to allow us to have the random scale to it. Now, if we put our cursor over the boolean, you can see that there's a little arrow pointing down. If we select that, a new menu pops up with all the different variables that we can choose. And the one that we want for this particular variable is a float. And what's fantastic about a float is that it holds decimal numbers, which the other variables do not. And this is terrific for percentage values, which is what we're going to be using. So we want to change that to a float. So we have a float variable, and it's named actor scale. So let us, and you can see now when we added the variable, it went into this components menu. So let's select the actor scale, and we're going to drag, whoops, I clicked it too many times. We're going to drag it into our work area. And what we want to do is put it to the right of our construction script node. And you're going to see that we have two choices, get actor scale or set actor scale. And we want to set the actor scale. And so now we have another node added to our work area. And so what we want to do is we want to connect the construction script node to our actor scale variable node. And what we're going to do is we're going to drag off the output pin on the construction script node and connect it to the input pin on our actor scale node. So this is what you have so far, and this is how your connection should be looking. Now what we want to do is we want to, I got these a little bit too close here. I like to have a nice tight organized area. But off of our actor scale node is this actor scale pin. It's a green pin in the bottom left-hand corner. And we want to drag off of that. And once we let go of our left mouse button, you're going to see that a new menu pops up. And so what we're going to do is we're going to now type random float in range. And I like to have all my connections nice and straight. And so what this is going to allow us to do is it's going to allow us to put the minimum size for our donut. I'm just going to call it our target a donut, and our maximum size. So how small do we want this to go and how big do we want this to go? If you leave your minimum at 0, your targets will disappear, and that will really be very challenging. The default size of the torus or the donut is pretty decent size. So I'm going to put in 0.5 to 1 because I don't really want it to get too huge or too small. But if you want to adjust these numbers, feel free to, depending on what asset you're using, and maybe you want to make it more challenging and have the targets disappear. That could be really interesting. But this is basically what this random float in range is going to do, is how big and how small are these targets going to get. Okay, and so now what we want to do is connect the actor scale set node, up here, the green one, to the set world scale 3D. And we're going to do white pin to white pin. And again, I like to keep everything as organized as possible so it's easy to follow the connections just in case you make a mistake or something. And so now what we want to do is we want to right click on the new scale pin on the set world scale 3D node. So this yellow pin right here, we want to right click on it and we want to split the structure pin. Now, right now, we have really no control. If it's kind of like having, like if you're in Photoshop and you have your XYZ scales all locked together. You move one and they all move. We really don't have much control over this. We can't operate XYZ independently. But when we split the structure pin on this, we can now independently, you know, change the variables for X, Y, and Z. By breaking this, it allows for a more uniform scaling to our targets. We have more control over what we are creating. And so, so you'll see that throughout this, the 25 chapter, or the 25 chapters, what am I, crazy? 25 pages in this tutorial, that we're going to be splitting this structure pin a few times. So get into this. So what we want to do is we want to, you know, connect from the actor scale node, this green output pin, to each of these new scale X, Y, and Z pins on the set world scale. And so this is what your connection should look like. And now what we're going to do is we're going to compile and we are going to save it. Now let's add the random movement. We will add a randomized behavior in order to create this movement. To do this, we will use an enumerator. And just so that you know, an enumerator is a list of named values. We'll use the list of named values to create a logic which will randomize the targets in our game. So what we want to do is we want to make sure that we name everything proper. So we're going to go back to our content browser. And I'm already in my target folder. But if you're not, make sure you go to Blueprints, double click on your target folder, and then in a blank area, right click. And what you're going to do is we are going to go to Blueprints down at the bottom and do enumeration. We're going to name this E for enumeration underscore target behavior. And then we're going to hit return. And so just so that you know, an enumeration or an enum is used to give names to integer values. They are basic programming features, and we're going to use them to move and scale our targets. So let's double click on our E target behavior to open it up. And up at the top here, there's a green plus sign and it says add enumerator. Let's hit that 4 times because we're going to have 4 different values for our targets. The first one, we're going to say nothing. We want nothing to happen. It's not going to move. It's not going to scale. And that's like my favorite one. And then we're going to do move horizontally. And we're going to do the next one, move vertically. And then the last one, we're going to do adjust scale. And so I always save. And then what we're going to do is go back to, I'm going to get rid of this materials. So I'm just going to click on the X to get rid of it so that it'll be easier to move back and forth. So next, what we want to do is we want to go back to our BP target tab, and we want to add the enumerator as a variable. So we're going to go back to our variable category. We're going to hit the plus sign, and we're going to name this one target behavior, and hit enter. And then we're going to click on that drop down arrow by where the float is, and we're going to type E underscore target, and you can see under the enum category, there's the one we want, E target behavior. We'll select that, and so we want to drag this now into our work area. And we're going to put it to the right of the set world scale 3D node. And we're going to choose set target behavior. I suppose it doesn't have to be that far away. And then what we're going to do is we're going to connect the set world scale 3D to the target behavior variable node. And so this is what your connection should look like thus far. So now we're going to assign a random behavior. We need to convert an integer into a byte, right? Because remember, integers hold numbers, and then our target behavior is a list of words. And you can't connect, in the coding world, you can't connect words directly to numbers. So in order to be able to make the connection, we need to convert an integer into a byte and then convert the byte into an enumerator. The reason we need to convert it is because enumerators hold words, not numbers, and integers hold numbers, not words. And in the scripting world, you just can't connect those two together. So let's right-click in the blank area of our blueprint underneath the set world scale 3D. And let's type random integer in range. And what we're going to do is, let me zoom in so you can see it a little bit. What we're going to do is we're going to set our minimum and our maximum value. And if you remember, 0 was nothing, and then 1 is move horizontal, 2 is move vertical, 3 is our random scale. So we want to keep our minimum at 0, and we want to change our maximum to 3. So this way, it's going to randomly choose between 0, 1, 2, and 3. Now, if you decide that you like your targets, all your targets moving, and you don't want any of them to stand still, come back here and change your minimum to 1. And then that way you'll have all your targets moving. So let's drag off the return value pin on the random integer in range node. And we're going to type 2 byte. And so you can see float to byte integer. And so what we're going to do now is we're going to connect the return value pin on the byte to our target behavior. And you can see that another node, it automatically, this is why I said it's kind of a GUI system, because it automatically created the conversion for us, and we didn't have to worry about it. So this is what your connection should look like right now. And what we want to do is we want to hit compile and save. So we can go back to our level and add a target to our level and kind of test it out and see what happens. So I need to actually move my content browser off so that I can actually drag it on here. And what I wanted to show you is, you see how it's kind of vibrating. It's actually scaling as I move it through. There we go. As I'm moving it through my environment. And so that means that our coding is working, which is fabulous. And so now, just a trick, if you don't know this, if you hold down the Alt key, you can actually create more. You duplicate these, hold down the Alt, and I have all 3 of them selected. And then if I do it again, so it's kind of cool. You can easily select and duplicate. Let's make lots of donuts. So here we have lots of donuts. That's a lot of donuts. So now, obviously, if we play the game, and I come get my gun, they're not moving because we haven't created the code to actually have these move when we start the game. But we know by just moving them that that our code is working. Okay, yay. So now I also can see by this that what size they are, and I think these are a good size. The small isn't too small, and the large isn't too large. So I'm okay with this. And if you want them bigger or larger, you can go back and you can adjust some of the settings. So now the next step is adding the random behaviors so that when the game begins, these will be moving around. So let's go back to our BB target, and we're going to go to our event graph, and we're going to delete these last two nodes, but we want to keep the event begin play. And so in our My Blueprint tab on the left, we're going to select the target behavior variable, and we're going to add it to our work area again. And we want to put this one just below our event begin play node. And this time we're going to hit get target behavior. So this is, so this is what we should have, and this is what it should look like. We're going to drag off of the target behavior node output pin, and we're going to type in switch on E target behavior. And so now this switch is going to help us be able to create the random behavior so that we can make sure that on nothing happens, and that it moves horizontally, it moves vertically, and it adjusts scale. So this is perfect. So now what we want to do is we want to connect the event begin play output pin to our switch. So white pin to white pin. So, and as you can see, this switch has multiple output pins, and it matches exactly what we created when we set up our enumerator. So now we can set what we want, right? So the first pin, we don't want to do anything. Second and third pins, we want to move horizontally, vertically. And and eventually we're going to get to the adjust scale. So when we're moving horizontally and vertically, we want to set a random location in order for those targets to move. And what's really neat is all we need is one variable vector. So let us create another variable, and we're going to name it destination location. And we're going to change our variable to a vector. And the reason we want to have a vector here is because a vector variable is able to hold numbers on the X, Y, and Z axis or coordinates. And that's exactly what we want, because we want to move horizontally and we want to move vertically. So we're going to drag this in twice. We're going to put both of them to the right of the switch, one up a little bit higher, one down. And we're going to choose the set. Oops, wrong one. And we're going to put the other one down here, and we're going to choose set. And so now what we want to do, remember I told you before we're going to do this quite a bit, is we're going to right click on our destination location pin, and we're going to select split struct pin. And we're going to do it on the bottom one as well. And so now we're going to have a lot of control over what's happening. So let's add the random behavior to both of these. So we want to change, so let's think about this for a second. So if we want to change horizontally, we want to use the x-axis. And when we change vertically, we want to use the z-axis. So let's connect the move horizontal to the top node x-axis. Whoops. I have to go up a little bit higher. I don't know what I was thinking. We want to go move horizontally up to the top node, and then vertical one to the bottom node. Okay. And so your connection should look like this. And so now we want to click on a blank area of your blueprint below the switch node. So we're going to right click on that and we're going to type random float in range. And so we want to go crazy on this, like 100 for the minimum and 250 for the maximum. And these are just units. And this will be the amount that they're moving horizontally and vertically. So it'll give us some nice movement, not crazy movement. They're not going to be like wildly all over the place, but it'll give us some nice movement. And so the return value here is this is where we're going to connect it to our destination location X on our top node, and we're going to connect it to our destination location Z on our bottom node. So this is what our connection should look like. And so to make sure our targets move, we need to now set up a timeline. So now we have everything connected so that they move, but that they should move on the proper axis and the proper duration or destination. But now let's make sure that they're actually going to move. So what we want to do is we want to drag off of the output node on the top destination location vector node, and we're going to type add timeline, and we're going to name this T_move. And we're going to connect the bottom one to it as well. And actually, we want to move these from the play. So hold down the control and do play from start because we want it to happen on the start. So this is what your connection should look like. And by holding down the control key, you can actually move your connections from pin to pin, which is really kind of nice. So now let us open up the timeline by double clicking on it, and let's make some adjustments here, right? So one of the things we want to do is we want to change our length to 1 second. This will make it so much easier when we need to make changes down the road because it's a shorter duration, and it'll just make things so much easier. You'll understand why as we move down the road. We want to click on the loop button so that it's blue, because we want the targets to constantly move. We don't want them to play 1 second and stop. We want it to play 1 second, come back, play again, play, and play again. Now what we want to do is we want to add a float track. So if we hit the plus track over here to the left of our length and we add a float, we're going to name our track alpha. And it's good to name things because if you don't, you're going to get lost really easily to where things are. And so now what we want to do is we want to add 3 keyframes. So if you right click at the 0, and we're going to add one at the half, and we're going to add one at 1 second. Now what's really great is that they have a little window up here, and you can see I'm off. I didn't hit the 0, exactly. I can come up here and I can just type in 0 and the keyframe will move. And I click on the half. I'm going to change that to 0.5. I'm going to change my value to 1 at the half second mark. And then I'm going to select the 1 second and make sure I'm at 1 and with my value at 0. So if I zoom out a little bit using my scroll wheel, I can see my graph. And this is what it should look like. Now, we want to have our movement to be smooth, and we want our curve to be smooth so that things are a little bit more fluid. So if you select all your keyframes and right click on one of them, hit user, and that will just make our curve nice and smooth. And so this will help with our movement. So let's compile and save this. And let's go back to our event graph. And what we want to do now is we want to connect our adjust scale, which is back here on our switch node, to the play from start on our timeline. So this is what your connections should look like. Because we do want to adjust the scale of the targets as well, we need to add another switch. A switch node reads the data input, and based on the value of that input, sends the execution flow out of the matching or optional default execution output. So in general, switches have an execution input and a data input for the type of data they evaluate. So now off of our T-move node, we want to drag off the update pin here, and we want to type in switch E underscore target behavior. And so now we want to drag another target behavior variable to our work area and place it just above our T-move node or our timeline mode. And so let's do that. And what we want to choose on this one is get behavior. I'm going to move it over a little bit so you can read it. And so what we want to do now is connect the selection pin on the switch right here, which is your green node, to our target behavior. So this is what our connection should look like. And so again, on nothing, we want to do nothing. And on our horizontal and vertical pins, we want to update the relative location of our targets. So from the components menu over here on our left-hand side of our work area, we want to go to our SM target, and we want to drag this to be above our new switch. And we're going to just drop it in there. Now, off of this node, we're going to drag, and we're going to type set relative location. And you know, I like to straighten out my connectors so that it's really easy, so we can see all the connections. And so now what we want to do is we want to connect the move horizontal output pin on our switch node to our input pin on our set relative location, so the top white pin. And we want to connect our move vertically output pin on our switch node to our set relative location, so the top white pin again. So this is what your connections should look like. So now on this node, our set relative location node, we want to drag off the new location pin. And we're going to type lerp vector. So again, it's a float. That's what the F is for. And so a lerp is a linear interpolation. It's a mathematical function that returns a value between two others at a point on a linear scale. Most commonly, it's used for moving or changing values over a period of time. So it linearly interprets the timeline between A and B. So let's select our SM target in our components tab over here. And if we go back to our details menu on the right, under transform, you can see under across from location that everything is 0, 0, 0. This is really good. And this is why it's good to have the target as a child of the default scene root, because now when we go to our lerp vector, we don't have to change any numbers. We can leave these at 0, 0, 0 because it matches our 0, 0, 0 up there. So hopefully that makes sense. And so now what we want to do is we want to just connect the destination location to our lerp to our lerp vector node. And what we're going to do is we're going to drag our destination location right onto the B pin. There we go. And so this is what your connections should look so far. And so now let's connect the alpha from our timeline, here's our alpha, to our alpha on our lerp vector. And basically, when this behavior is selected, it will move it to its destination location, and it will do that on a loop. So hopefully this is making sense for you guys. So for our targets, it's going to be very similar to what we did on the construction script. So let's select and drag another SM target into our work area. And so we're going to place it right below our lerp vector. And now let's drag off of our target, SM target node, and we're going to type set world, set world scale. I'm so used to saying location, I'm typing location. We want set world scale because now we're about scaling our targets. And from this switch, our second switch, we want to drag the adjust scale pin to our input pin on our set world scale. So now we're saying, okay, this is how we are going to be adjusting our scale of our targets. So this is what your target, or this is what your node should look like so far. And what we're going to do is we're going to drag off this new scale pin, and we're going to type set world scale 3D. Oh, pardon me. It's been a long day. My apologies. What we're going to do is we're going to create another lerp vector. I don't know what I was thinking. We want to go from our set world scale 3D to a lerp vector so that we can have all the control in the world for our targets. So the A value on our lerp vector is going to be the scale of our actor at the start of the game. And we know that because we stored the actor scale variable. So if we right click on our A input on the lerp vector node, we're going to hit split struct pin. And now what we're going to do is drag the actor scale variable to the left of this new lerp node. And from the components category, we're going to choose get actor scale. And we're going to connect this to, we're going to connect the output pin from the actor scale node to each of these AX, AY, and AZ. And so that's how your connections should look. Thus far. Now what we want to do is we want to connect the alpha input pin on our lerp vector to the timeline. So we're going to go from here all the way up to there. So this is what you should have so far. And you guessed it, we are going to split struct the B pin now. So this is what we have. So what we want to do now is we want to create an option for these targets to randomly scale. So we're going to add a multiplier to this, and we're going to put 1.5. So remember, we go from 0.5 to 1. And so now if we multiply by 1.5, then, you know, the scale is going to randomly scale between those sizes. So let us now drag off this actor scale pin and type multiply. And we're going to pick the float multiply. And what we want to do is in this blank area, we're going to type 1.5. And then we're going to connect like that. And so that's what it's going to look like. And so what we want to do is we're going to compile and we're going to save this. And let's go to our game and hit play. And let's see if this works. Oh my. These donuts are moving. So it's working. Our code is working. So that's a very good thing. Very good. And so, but as you can see, they were moving very together, right? It was very synchronous moving. And I think some of them moved a little too fast, but so let's change that. Let's make it more random, and let's change that they don't move quite so fast. So let's go back to our BP target, and we're going back to our event graph. And so what we're going to do is we're going to select everything from our timeline, our T move down. I want to give myself some work area. That's probably like way too much space, but I always tend to not give myself enough space. So I want to give myself some space here. And we just want to move them to the right a little bit so that we can have some free space. And we're going to right click in the blank area, and we're going to type get T move. And you can see under variables B target, get T move. So basically what this is it's referencing our timeline node. So this is a node that's is a reference to our timeline node. So let's drag off of this pin, and we are going to type set play rate, and we'll move these over a little bit. And so what we want to do now is reconnect this timeline by holding down the control key, and we're going to move these connections, all three of these connections, to the set play rate node. So your connection should look like this. And we want to now connect this one, set play rate node, to the play from start node. So this is kind of how your connections should look at this point. And so from the set play rate node, there is this new rate pin, and we're going to drag off of it, and we're going to type divide. this is the node we want. And what we want to do is we want to put, whoops, I don't want to put 10 in. I want to put 1 in. Put 1 in the top and bottom value boxes. And we're going to drag off of the bottom pin. And we're going to type random float. I can't type in range. I like to have all my connections nice and smooth. And so because I thought my targets were moving too fast, I want to slow them down. And by adding this random float, I can put in a minimum amount of time and a maximum amount of time that these targets should be moving. So like, I'm going to try 1.5 seconds for a minimum and 3 seconds. Oops, not 0.3. Let's try that again. 3 seconds for the maximum. So I don't want them to move faster than 3 seconds. I want to move slower than 1.5. And so, you know, this is what your connection should look like at this point. And we can compile and we can save. And now let's give this a go. Oh, yes, we can see that they're moving way slower. So that's nice. And, you know, if you guys, you know, want them to move slower or faster, you know, feel free to change those numbers. So right now I'm going to say I like these targets and I like that some of them don't move. So I'm going to leave this as is. Let's go back to our BP target blueprint and let's go to our construction script tab. And so what we want to do now is we want to go to our random integer range. And, you know, I wanted to just remind you guys that if you want not to have any of your targets standing still, you're going to want to change this 0 to a 1. I prefer having some of my targets not moving, so I'm going to leave it at 0, but I just wanted to kind of remind you that if you decided I want them all to move, change that 0 to a 1. All right. So now what I want to do is I want to go back to the event graph. And what I want to do is I want to show you that we can organize our nodes. We can color code them, I guess you could say, or colorize them. And so like if I select all my nodes and I hit C, it puts a box around them. And so I can name this. And so I can come right up here and I can name them. And so like we could name this begin play random behavior logic. And then I can change the color. And if I wanted to, I could increase my font size if I thought that was too small. Boy, that is really hot pink. And then I can select, you know, the nodes from the timeline over, and I can hit C again. Oops. I don't think there we go. Nope, I think I'm selecting all of them. I'm accidentally selecting. Okay, so now I can hit C again. And so now I have a box within a box that I can colorize it, which is really, really kind of cool. And so like this one, let's say we call it execute behavior. And if you wanted to stay with the color theme, we could go pink and we can make it dark. And then we can select these ones and we can hit C again. And then we can say set behavior value. And staying with our pink theme, we can make it nice and dark. So it's really kind of cool. So that way, you know, you can remember kind of what you did here. And you can move these things around to give them space and everything. So I just thought in case you wanted to organize them or whatnot, that would be how you do it. So in the next video, what I'm going to do is I'm going to show you how to create a target spawner, and we're going to also put a cap on the target spawner, and we're going to also make our, when we hit our target, make the target disappear and have more targets spawn once it's over. So hang on, there's another video coming your way.